And ourselves, as experimentalists in ecological psychology, that the linkage between the ontology that we need to use and that of classical mechanics, etc., doesn't fit very well. It is not appropriate. What we don't quite understand yet, status unknown, is the relationship between the ontology that we seek to abide and that of quantum mechanics. And the difference may not be as great as we have been led to think. That's part of the message today. I'm going to consider non-locality and superposition. Standard quantum phenomena, standard quantum constraints on the broader thinking, and I'd like to show you that they are prominent, possibly, in matters of perception at the ecological scale. Here's history. Light simulates environment. Simulations are sent into mind. The object A is out there in the world. The light reflected from it, to be said more appropriately, creates a simulation which is then transported inside the observer. The observer is B, and what we have is the simulative assumption, light simulates objects, and the projective assumption. That thing which is simulated goes inside the head. And there is some device, some capability that sees the thing inside the head. This was first advanced by Pythagoras, Euclid, and Plato. This is one of their more amusing perspectives, by the way. Light comes from the person. It produces the simulacrum, and the simulacrum then proceeds inside the head. And this, of course, is what most people in cognitive science, psychology in the large, and the man in the street actually think about the Cartesian homunculus. Very hard to get away. In fact, in cognitive science, we often find ourselves having to discuss the homunculus. And we use the word. You see it in your readings. The locality assumption. All causes are local by contact. The principle of nearby action. Given two things, A and B, look at the images above. A must make physical contact with B at some moment in time. That is, be contiguous with B if A is to cause a change in B. And by B, I seriously mean the little man that's sitting there marked with the letter B. Greek scientists required that we abide these two assertions. Otherwise, they feared the science they were trying to create would get out of hand. So these are foundational: the locality assumption and the principle of nearby action. These assumptions dictate what? They dictate a local causal theory of perception and a hypothesis of an internal agent, a human analog or homunculus. So let's turn to the outness problem, also known as the externality problem. It was first introduced by the Malebranche, an Italian scholar who found himself delighted by Descartes. And Malebranche gave the word externality to this problem when it got translated into English. The translator translated it into outness. The enigma of there, not here. Given visual entities here in the mind, how are they situated there in the environment in a manner that is necessarily coordinate with the environmental entities to which they belong? William James, he was always a delight. He called this phenomenon visual hallucination. He derided believers in this perspective, but of course he never won this battle. He won
Veridical hallucination.
I said veridical. Veridical. Did I say it visual? Or veridical? Veridical. William James. But what should be underlined even more is that this outness problem sits behind the great work of Kant. In fact, the geometries that we get from Kant, the thinking about space that we get from Kant, is being driven by the outness problem, the externality problem. Let's do the reading. by means of outer sense, the property of the mind, we represent objects as outside us, and all as in space. Space is not an empirical concept that has been drawn from outer experiences, to the contrary, basically. For in order for certain sensations to be related to something outside, here, read Kant, pick up the words, tremendous influence upon philosophy, psychology, and physics. Thus, in order for me to represent them as outside and next to one another, thus not merely as different, but as in different places, the representation of space must already be their ground. Space is a necessary representation, a priori. These are powerful words. They were uttered a long time ago. Let's look at someone more recent, the great Baker, the greatest sensory physiologist of his time. This is in his Nobel laureate address. The funneling of sensations into a space outside the body is an important feature. You miserable blighters sitting there, right? Think about it. You've gone through undergraduate school. You've been hearing this kind of argument for most of your lives. What are you saying? The funneling of sensations outside the body is an important feature, because you've got to get them from here to out there. You've got to put them where they really belong. You have to put them where they really belong. Free control is practically all about behavior, probably learned early in life. Can you imagine the nature of this learning? What kind of learning would this be? The images that are in your mind, your mental content, are having to be projected out. Look at all the things in this room. If you could turn your eyes around and look, they have to be put in exactly the right places. Veridical hallucination. How do we resolve the outness problem? Non-locality. The assumption of non-locality. 16th through 19th centuries, all causal order was temporal order. Thus the locality assumption, thus the principle of nearby action, A on B, the internal representation of A here in B, the veridical hallucination of A there at A, and basically in the parenthetical, there where A is not here where B is. That's what Immanuel Kant was after in short. 20th century to 21st centuries, some causal order does not equal temporal order. Some causal order is logical order. And for Bell's world, no before and after. This is the non-locality assumption. Look how uncluttered this diagram is. Look at this diagram. It's completely boring. All introductory psychology textbooks will be thrown out the window. There's nothing here. As long as you've got that, you've got introductory psychology textbooks. If you don't have that, you don't have any psychology. A lot of people will be put out of business. How do you resolve the outness problem then? Two-term relation. And this, of course, is where James Gibson went. Information is information about in the sense of specificity of energy distributions too. Here's the information hypothesis. Perception of X is specific to information about X, period. Charge of science is to understand that notion of information. To understand how it is that we resolve the outness problem. Implication 1, incorrigibility of information, unalterable by biological, neural, psychological factors. Transparency of biological, neural, psychological factors. Information is engaged frankly, without affectation. As I stand here before you, registering the optical structure that's available to my eyes, I am doing so frankly. If I did otherwise, it would be a horror story. Without corruption. It has to be so. Otherwise, there's no getting around in the world. We wouldn't be holding this particular meeting here. It would be impossible. could not do it. Implication 2, non-local causality of information means simply this: systematicity of perception distally caused, and that word would have to be reworked, by systematicity of environment and relation of organism to environment. Implication 3, ontologizing epistemology. Knowledge of environment, body, and environment-body relations is grounded in and acquired through the specificity of information to environment, body, and environment-body relations. So that's the outness model. You may never have heard of it, you probably have never thought about it, but I suspect once you've heard it and thought about it, you'll see why we cannot live with it. There's something terribly wrong with the way we think about the problem conception. Superposition. This is the observation problem. So I've taken you through the outness problem, let me now take you through the observation problem. Finding a description of the states of everyday macroscopic objects compatible with the formal principle of superposition. This is just from quantum theory. And here's how we often say this particular superposition. If X can be in any possible state I, and it could also be in any other possible state J, then X can thus be in a state in which both are possible, states I and J, present in the same time and with equal probability. Here's what you may not know. This is Bohr and Einstein. This is a wonderful discussion between Bohr and Einstein. Look at the words here. The quantum mechanical description cannot be understood without an alternative quantum compatible conception of everyday objects. Of everyday objects. These things. That thing. Even worse, that thing. Everyday objects. A consistent interpretation of quantum mechanics requires macroscopic objects more propertied than those identified in classical mechanics. They were after a new description at this scale of nature. As far as they were concerned, they were both skeptical about quantum theory. And their skepticism was tied to this issue. If you didn't have a richer description of the world, you cannot interpret quantum theory. You can do a lot with it, but you can never know what you're doing. This is what their concern is. We do tons of things with it, but we don't exactly know what we're doing. Primary, secondary, and relational properties. I wish to show you where it is that the concept of affordance probably and should sit in the ontology. This is the primary quality. Predication of property A, 20 centimeters, to a thing B, a line drawn in the sand, relative to some other thing, C, a ruler, is primary if and only if it is expressed by B's relation R to C, but does not inhere in either R or C. That's the primary quality. The primary qualities are those things out of which we have built contemporary physics, the primary qualities. Galileo and Newton. This is their staple, the primary qualities. Identify them. How many of them are there? There aren't that many. Mass, space, time. There aren't that many. Go in there and find the particular quantities you need to speak about, probably half a dozen. This is secondary quality. This is the predication. If you don't like the word predication, if you're looking for an easy word, assignment. The assignment of property A to thing B, in this case, black, the label, to that black line, relative to some other thing C, in this case the other thing is a biological system, is secondary if and only if A is expressed by B's relation R to C and inheres in C. Colors in here. You ever read color theory? Color theory. We cannot get out of this trap. Pick up your textbooks. There's no color here. I put color here. Just read the textbook. I put color here. Look around, every one of you. Look around. You're putting the colors there. That's the textbooks. That's psychology, physiology, neuroscience. neither P, the primary, nor S, the secondary, applies to objects of the quantum scale. Neither of these are relevant to quantum mechanics. Neither of them hold at the quantum level. At the quantum level, this is what holds. Predication of property A to thing B relative to some other thing C is relational if and only if A is expressed by and actualized by. Only if it's expressed by and actualized by B's relation to C. And I need this follow-up. A exists potentially in B as a disposition. I'm a very fan of disposition, by the way, as some of you know. Regardless of whether an object or instrument exists that can actually actualize it. Can actually. You need some instrument to get the thing realized. R is a new kind of primary quality. It is not a third ontological category. Only this applies to objects of the quantum scale. And only this applies to affordances. You cannot do affordances with primary and secondary qualities. Only that applies to affordances. This is the definition of affordance. That's what it is. I'm saying the following. Affordance is a new kind of primary quality. The harder we work to understand this concept, the better off we will be. It's a new kind of primary quality. Think about the sciences. The hardest thing for us to come to terms with is living things. There are 96 phyla, and then there are those two great kingdoms of archaea and bacteria. There are millions upon millions upon millions upon millions of biological systems that go about their daily basis, measuring, acting, transforming, building, constructing, destroying, etc., etc. And that is the theory we have to get. That's the big theory. The assumption that what we have in mechanics and quantum mechanics is enough is wrong. It's got to handle this problem. And this problem starts with affordance, a new primary quality. A stone is superposition. Its potential properties are actualized only when specific spatial temporal relations hold, and it is identical to none of them. Predicate paperweight of stone. I've got a nice grey stone here. This is one of Gamartin's favourites. He likes grey stones. I use it as a doorstep. What's that thing? Oh, it's a doorstep. Oh, you mean that grey stone? Yeah. What's that thing? Oh, it's a paperweight. Oh, you mean that grey stone? Yeah. It's a scraper. It's a pounder. This is me, of course, doing affordance language. Right? It affords pounding, it affords scraping, it affords paper weighting, it affords door stopping. This digger wasp fits nicely with the earlier lecture on the, not the monkeys, the chimpanzees. This digger wasp, it finds a particular stone which it then uses to scrape the surface where it's going to build a nest in which it will put its eggs. And it uses the stone to scrape, it uses it to hammer down the opening when it's filled in the soil. So it uses that same stone, puts it in and pounds the opening, makes that nice and flat, and it uses it then as a thing to cover up the place that it has built. Builds a nest, builds it in, covers it over using the stone, and puts the stone on top. This is stone as primary predicative property, giving us height. Here it is a relational impredicative property, giving us, look at the impredicative property, the relational property, jump up on a bit, not crawl up a bit. That's for the cat. Crawl up a ball, not jump up on a ball. That's for the ant. Two different and complementary physical conceptions of a macroscopic object, sustaining two different and complementary conceptions of causality. Both jump up on a ball and not jump up on a ball, are they, we might ask, you may raise the question, are they ecological parallels to Schrödinger's cat? What the environment affords is objective, real, and physical, but not in a non-classical sense. In this simple diagram, that post has a primary predicative property called height. It's objective in the conventional sense, expressed by relation to another thing. Now to biology, now to living things. The post's relational impredicative properties jump up onable for squiggle, but not for mouse. Walk roundable for both, but pass throughable for neither. Jump up onable is real in an impredicative sense, defined in terms, and this is what impredicative means, defined in terms of the system of which the post is a part. It's physical in a quantum-compatible superpositional sense. Many possibilities simultaneously and equally present. Jump up, onable, climb upable, perch onable, land onable, leap fromable, or groundable, hide behindable. That post, look at its properties. Understandable in an impredicative sense, understandable in a tremendously relational sense. This primary quality is unbelievably rich. It is so rich it can accommodate all biology, all living things. So here we are. We can ask the question, is affordance the conception of macroscopic objects that Bohr and Einstein were after to interpret quantum mechanics consistently at micro and macro scales? The physicist Martin believes so, and the wonderful physicist philosopher Hooray thinks likely. I don't want you to read all of this, but you may enjoy it. I just want you to recognize that others have seen the fact that Gibson was doing quantum theory. Gibson's conceptions were quantum. This is the wonderful scholar Edwin Boring in his review of the 1966 book, I Take You to the Red. Well, Newton got away with action at a distance, preposterous as it seemed, and perhaps Gibson could ultimately win our ascent to a temporal vacuum between a cause and its effect, but it would require revolutionary thinking. See, some have read Gibson as already, as it were, playing with the notion that the right route for us to go was in some route that would be like quantum mechanics, but beyond quantum mechanics. Thank you. Some